Alright, hey guys, welcome back. This is your final lesson of the semester. It's me, Miss Moncrief, and I am so honored that they saved the final lesson for me, because I just like lessons. Anyways, sorry. Today we are looking at systems of linear inequalities, and I hope you were picking up some context clues from we looked at systems of equations and now moving into inequalities. We know that a system means we have two or more, right? And instead of having equations this time, we'll have inequalities. So let's keep going. So before we move into actually looking at the systems, let's recall solutions to linear inequalities. So we want to determine which ordered pairs are part of the solution for each inequality. Enter S for solution or NS for not a solution. So on A, we were given 3x plus y is greater than or equal to 6. So my first ordered pair is 4, 3. We just want to see if 4, 3 is a solution to this inequality. Well, what are we going to do? You guys remember? Alright, we're going to plug in 4 for x and 3 for y. And then we're just going to see whatever we get out is greater than or equal to 6. So it should look something like 3 times, what was x? 4. Oh, I just realized I wrote x over this 3. My bad. That should say y. Plus, and what was my y? 3 is greater than or equal to 6. Now, I know we probably know what 3 times 4 is and add 3, but to save some time, we can just put in 3 times 4 plus 3. And let's see what we got. We got 15. So we have 15 is greater than or equal to 6. Is that true? Yes or no? Yes, so this is in fact a solution. Alright, let's keep going. I have 3x plus y is greater than or equal to 6, and now I want to check negative 2, 4. Let's do the same thing. Negative 2 is x, and 4 is what, everyone? Y. So we have 3 times negative 2 plus 4 is greater than or equal to, and again, I know you guys can do all that math, but let's just check it out. 3 times negative 2 plus 4, and that got us negative 2 is greater than or equal to 6. Is negative 2 greater than or equal to 6? No, it's smaller. I'm going to do that in red. No, negative 2 is not greater than or equal to 6. So this is not a solution. Alright, in our last one, we have negative 5 for x and negative 3 for y. So we are just going to plug those in like we have been. So we have 3 times, what was x? You betcha, negative 5. Negative 5 minus, and what was y? A negative 3 is greater than or equal to 6. And all we got to do is plug in that. So 3 times negative 5 minus negative 3. And what do we get? We got negative 12. So is negative 12 it's negative 15. Yes, negative 12. Is negative 12 greater than or equal to 6? Waiting for an answer. Just kidding. No, it's not. So again, that is not a solution. Again, that is not a solution. Alright, now let's go ahead and check the next ones. Let's go ahead and check the next one. So we have 3x minus 2y is less than 5. So this time we were given 4 for x and negative 4 for y. So let's plug them in. I have 3 times, and what was x? You're right, it was 4. Minus 2, and what did I plug in for y? Negative 4 is less than 5. And again, the best way to do this is just plugging it in your calculator. Make sure you're plugging in this side completely like you have it written out. Don't deviate from that or anything like that. So we have 3 parentheses 4 minus 2 parentheses negative 4. And what do we get? We get 20. So we want to know, is 20 less than 5? Is 20 less than 5? No, it's not. So this is not a solution. Alright, so now let's check another one. What were we given for x this time? Very good, it was 3. And what were we given for y? Even better, it was 5. So that means we have 3 times, what was x? 3. Minus 2 times 5. And we want to know, is that, oh no, I forgot to put that in blue. 2 times 5. And we want to know, is that less than 5? So we have 3 parentheses 3 minus 2 parentheses 5. And what do we get? Negative 1. So is negative 1 less than 5? Well, actually, yeah, it is. It is less. Negative 1 is less than 5. So this is a solution. All right, and let's check our final one. Our final one. What were we given for x? 5. And what were we given for y? 2. So now we're just going to plug those in. So we have 3 parentheses, and what was x? 5 minus 2. Oh no, that's not what I meant to do. Minus 2 parentheses, and what was y? 2 is less than 5. So let's see what 3 times 5 minus 2 times 2 was. What do we get? We got 11. So is 11 less than 5? No, 11 is actually bigger than 5. 6 bigger than 5, so it is not a solution. Oh, I guess I could have X'd out like it did. Alright, anyways, we knew that one was wrong. Alright, so now that we've made sure we remembered how to algebraically figure out whether or not that ordered pair is a solution to the inequality, let's go ahead and start looking at systems. So I glossed over it a second ago, and it's about what is a system of linear inequalities. So 2 or more linear inequalities for which solutions make all of the equations true. Make all of the equations true. That means it has to be a true statement for both of them, not just one, both. Solutions are ordered pairs in the region where shading overlaps and on the shared solid line. So where shading overlaps and there is a shared solid line. So let's look at an example of that. We were given first we were given these two systems of y is less than 2x plus 1 and y is greater than or equal to negative 1/2 minus 4. So we just want to talk about what is going to be a solution here. But hopefully you remember how to graph these by kind of graphing it like we would a we would any other line, and then shading. So looking at this one, where would we start? We'd start at 1, and how many would we go up? 2. So 2, 1, 2 over 1. And 1, 2 over 1. We continue that pattern to draw this. How do we know it was a dotted line? It was just less than. And where do we know to shade? Below. And again, with this one, we have y is greater than or equal to negative 1/2 x minus 4. Where do we start? Negative 4. So since the slope was negative, we go down 1 over 2, down 1 over 2, and kind of keep going. And then we notice that it's greater than or equal to, so the equal to meant we needed to draw a line, and the greater than meant we needed to shade everywhere above that line. So, even though we did all that shading, the region that we only care about right now is this region B. Why region B? Because region B is where the shading overlaps. We only care about where the shading overlaps. So let's take a look at how this works out. So let's pick a point from region A. All right, let's pick negative 2, 2. So that point is right here, negative 2, 2. So in order to figure out if it's a solution to both of them, that means we need to plug it into both of them. So let's start by plugging it into the first one. We have negative 2, 2, and plugging it in. So we plugged in negative 2 for x and 2 for y. So here we are again with negative 2 for x and 2 for y into the first equation. So now it's negative 2 times 2. What's 2 times negative 2? Negative 4 plus 1. So we have 2 times negative 2 plus 1. And that gets us... Alright, there's a little typo on here, but that gets us negative... That's going to get us negative 3. Negative 3. Now, so that means we have 2 is less than negative 3. Is 2 less than negative 3? No, so that means this statement is, in fact, false. Now let's do the next one. So we have 2 for y again, here, and negative 2 for x. So let's plug it in to make sure we got the answer right here. So we have alpha y equals 1, negative 1 over 2 times negative 2 minus 4. And we got negative 3. So we have 2 is greater than negative 3. Would you rather have $2 or negative $3? That's right. So that means since this is a true statement, it is true for just the second line, which makes sense because it's in that shaded region that only the second line has shaded. All right, now let's go to region B. Region B, we want to see if 6, 2 is going to be one of our solutions. So 6, 2 would be 1, 2, 3, 4, 5, 6, and 1, 2, right here where the P is, pretty much. So, but of course we want to check it real quick algebraically to make sure we are right. What are we going to plug in for x? 6, and what are we going to plug in for y? 2. So that means we have 2 is less than 2 times 6 plus 1. And what is 2 times 6 plus 1? All right, that's 13. So is 2 less than 13? Yes, so this statement is true. Yay. All right, and now let's check it again. For the other equation, we checked the first one, it checked out. So now we want to plug in 2 for y. So 2 is greater than or equal to negative 1/2 times 6 minus 4. So let's plug in that negative 1/2 times 6 minus 4. Alpha y equals 1, negative 1 over 2 times 6 minus 4. And what do we get? Negative 7. So is 2 greater than or equal to negative 7? Yeah, so this one also checks out, and we're cool with it. So 6,2 is in fact a solution to this system. So we like 6,2. 6,2 is cool. Is a solution. All right. Now let's check region C. So region C is just this kind of reddish region right there. We don't know. So we want to check. We want to again check algebraically like we have. So let's find 4, negative 8 on the graph though. So we have 4 and negative 1, 2, 3, 4, 5, 6, 7, 8. So that would be like right about here, I'm pretty sure. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to be right here on the line. So 4, negative 8. All right, here we go. 4, negative 8. Now, is 4, negative 8 in the overlapping region? No. But I still want to check it out algebraically with x and y. So what are we plugging in for x here? 4. And what are we plugging in for y? Negative 8. So we have negative 8 is less than, that might be more distracting than it's worth, negative 8, no, wrong, negative 8 is less than 2 times 4 plus 1. So we have 2 times 4 plus 1. And what do we get? 9. So is negative 8 less than 9? Yeah, so it's true for that one, which is cool. But let's check the next one. We have negative 8 is greater than or equal to 1/2 times 4 minus 4. So let's put it in there. Alpha y equals 1, negative 1 over 2 times 4 minus 4. And that got us negative 6. So is negative 8 greater than or equal to negative 6? No. Remember, if the number, when it has a negative, if it's like, in quotes, the bigger number, then it's actually smaller. Okay? So this one is not a solution. 4, negative 8 is not a solution. All right, and now let's check region D. Region D, where we have 5. We have 5, negative 4. 1, 2, 3, 4, right here. Now, is this in a region of any shading? So will this one even be a solution to any of them? I don't know. Let's check it out. So we have, we have x is negative 5 and negative 4 is y. So, yeah. So we had another typo here. Yeah, we had another typo here. Just bear with me a minute. Need to make sure we're plugging in all of the right things for x and y. So here, what are we plugging in for x? Negative 5. And what are we plugging in for y? Negative 4. So let's see if 2 times times negative 5 plus 1. What is that? Oops, I typed something in wrong. I put a minus sign. It happens all the time. It's 2 times negative 5 plus 1. And what do we get? We get negative 9. So we have negative 9. And did anything change about this negative 4? No, so bring it down. So is negative 4 less than negative 9? No, so this one's not true. So this one's false for the first inequality. All right, let's check it for the second inequality. Again, what are we plugging in for y? Negative 4. And what are we plugging in for x? Negative 5. So let's check that one out. We have alpha y equals 1, negative 1 over 2 times negative 5 minus 4. And what do we get? Negative 3 over 2. So we have negative 3 over 2. And then we have negative 4. So is negative 3 over 2, so is negative 4 greater than or equal to negative 3 over 2? Now, it might be hard to tell that with that being a fraction, so one way we can do is change that to a decimal by just doing negative 3 divided by 2. And that is negative 1.5. So is negative 4 greater than or equal to negative 1.5? Yeah, no, it's not. Remember, it flops around. Remember when the negatives are there, the larger the number looks, the smaller it actually is. So that means this statement is also false. So negative 5, negative 4 is not a solution. Negative 5, negative 4 is not a solution. All right, now we need to do the shared line. So we're looking at just on this shared line. Now, we have the point 4, negative 6. So 1, 2, 3, 4, 5, 6. So this point right here on 4, negative 6. So what are we going to plug in for x? You betcha that would be 4. And what are we going to plug in for y? You're right, that would be negative 6. So we have negative 6 is less than 2 times 4 plus 1. So what is 2 times 4 plus 1? All right, that's 9. Is negative 6 less than 9? 100% it is, so that part is true. Now we want to check, is negative 6 greater than or equal to negative 1/2 times 4 minus 4. So we have alpha y equals 1, negative 1 over 2 times 4 minus 4. And what do we get? Negative 6. We have negative 6 is greater than or equal to negative 6. Is that true? I mean, yeah, they're equal, so it's true. So that means it works out for both of them. Perfect, it does. So that means this one is a solution. Oof. So of all the points we just checked, of all of them, we only had 2 that were a solution. We had 6, 2, and 4, negative 6. So 6, 2, and 4, negative 6 are solutions. There are an infinite number of points in region B and on the shared line. So with that being said, if there's an infinite number here, inequalities have infinitely many solutions. That just means there's a lot of solutions to them. All right, let's go to the next one. All right, so we want to graph the system of inequalities first. So looking at example 2, we want to graph the system of inequalities. So, sorry, I was checking how much we had left. So we really only have this example where we graph and then 2 examples where we write them. So let's make it through. We can do this. I have faith in us. So we want to graph the system of inequalities. The first one is negative 2x minus 3y is less than or equal to 6. Now, do these really look like they're ready to graph? No, remember, in order for them to be ready to graph, they have to have a y by themselves. I normally say set equal to y, but these aren't equal signs. So we have to solve for y in both of them. Let's start with the first one. So we have negative 2x minus 3y is less than or equal to negative 6. Now, what's the first step in getting y alone? You're right, we want to get rid of this 2x by adding it to both sides of the inequality. What happens on the left? It cancels, and we have negative 3y is less than or equal to 2x minus 6. All right, now what do we need to do to get y by itself? You're right, we have to divide by this negative 3. Divide by negative 3. Okay, what happens on the left? It cancels, and we're left with y. So we'll talk about the sign in a second. Can we simplify 2 over 3 any more? So we have negative 2/3 x. And then what is negative 6 divided by negative 3? Positive 2. Now, this sign right here, we have less than or equal to, but we divided by negative 3, so it's going to have to flip to greater than or equal to. So we are truly left with y is greater than or equal to negative 2/3 x plus 2. All right, we did one of them. Now it's time to go again. So we negative x plus 2y. Actually, let's go ahead and graph this one. All right, so looking at y is greater than or equal to negative 2/3 x plus 2, where do we want to start? You're right, we want to start, and I'm going to do this one. We want to start with this intercept. And what's my intercept? 2. So let's go plot 2. My y-intercept of 2. All right, now we want to graph the slope. So since it's negative, I'm going to go down. And how many am I going to go down? 2. So 1, 2. And how many am I going to go to the right? 3. 1, 2, 3. Again, down 2, 1, 2, over 3. 1, 2, 3. Down 2, over 1, 2, 3. Up 2, 1, 2, left. 1, 2, 3. 1, 2, 1, 2, 3. I just kind of like to get all of them on the graph. All right, so now let's talk about what kind of line it's going to have to be. Is it solid or dashed? That's right, it's solid because we have this line underneath it. So that means we need to draw a line connecting all of our beautiful dots. All right, and so now we need to know where is it shaded. Since it's greater than, are we shading above or below? You're right, we are shading above. So just go ahead and shade everywhere above it. Shading's not my favorite part of this. All right, so now we have our first one graph. So let's move on to our next one. We have negative x plus 2y is less than negative 6. What's the first thing we want to move in order to get y alone? You're right, we want to move the x. So add x to both sides. What happens on the left? Cancels, and we have 2y is less than x minus 6. All right, what's the last thing we got to do to get y alone? You're right, divide by 2. What happens on the left? Cancels. So we're left with y. I'm not dividing or multiplying by a negative, so my sign changes the same. I can't simplify x over 2 anymore, so I have 1/2 x. And what is negative 6 divided by 2? Negative 3. All right, now let's graph this one. Again, I want to start at my y-intercept, which is -3. So 1, 2, 3. All right, and now I want to take my slope and plot more points. So my slope is 1/2, so I'm going to go up 1 and to the right 2. Again. It gets kind of tricky around here. And there we go. Down 1, 2, 1, 2. Very good. All right, so now that we've plotted all those points, let's think about the line. Now, is my line dotted or is my line dashed or solid? There is no equal to line underneath, so it's dashed. So just draw some extra lines in between those two dots, but do not connect them. This does not connect the dots. And add your arrows on the end because you know we love a good arrow. We love arrows on graphs. All right, and now is it shaded above or below? Since it's less than, we are in fact shading below. Okay, so now let's talk about where my solution is going to be. Is my solution here in just this white region? No. Is it here in just the pink region? No. Is it here in just the blue region? No, it is right here in this little triangle. And I say triangle, but like it keeps going, right? Those lines continue on forever and ever. Keeps going. So now we want to see, is 6-2 a solution? We want to prove our answer algebraically before we, check our graph. So what are we going to plug in for x? 6. And what are we going to plug in for y? 2. So let's start with the first equation. And you can use it from either one of the forms that we have. So let's use our one that we've already solved for. So we have solved for y. So we have 2 is greater than or equal to -2/3 times 6 plus 2. So we know nothing about 2 and greater than or equal to are going to change. So let's go ahead and bring them down. But now let's simplify this -2/3 times 6 plus 2. So I have alpha y equals 1, -2/3 times 6 plus 2. And what do I get? -2. So now, is 2 greater than or equal to -2? Yes, it is. So far it works out. It is a solution to our first one. Now let's check our second one, where we have 2 is less than 1/2 times 6 minus 3. So we know nothing's going to change about the 2 and less than, so let's bring it down. 2 is less than. All right, and now let's simplify this. The 1/2 times 6 minus 3. So we have alpha y equals 1/2 times 6 minus 3. And what do we get? 0. So is 2 less than 0? No, so this is no, not a solution. So now let's go find this on our graph. We have 1, 2, I'm going to put it in purple. We have 1, 2, 3, 4, 5, 6, and we go 1, 2. So here is 6, 2. Is that in our shared region? No. So this is definitely not a solution. This is definitely not a solution. All right, now let's go to example number 3. So example number 3 is writing a system of inequalities. Oh, also, before we move into example number 3, when it gets to problems like example number 2, today in your lesson and in your BellWorks and anywhere else, you have to send your teacher pictures of your graph. So you will do them on paper the best you can. We're not looking for ultimate artistic ability. We're just looking for clarity. So make sure you do the graph on the paper and then you just send us a picture of it. Email, Schoology message. Your teacher will probably send you more information on how she wants that. But other than that, make sure you're sending a picture of the graph and label them 1, 2, 3, 4, whatever number they are. All right, so now let's get to writing a system of inequalities. So writing a system of inequalities is just like we're just writing the inequalities, but we just have 2 now. That's all it is. So let's look at inequality A. So I'm going to do inequality A. That looks like a purple or a dark blue. We'll go dark blue. So let's find the y-intercept of our dark blue line. It gets a little tricky. You got to follow along because there's 2. All right, and here it is. So what is that y-intercept? All right, and remember, because it says y-intercept, you have to write it as an ordered pair. So let's go ahead and do 0, comma, and what's number is this? -2. All right, so now that we've found one point, let's find another point to the right of it. All right, here's one right here. And if I wanted to find it on the graph, how many let's see, do we go up or down to reach that point to the right? We go up. How many do we go up? 1, 2. And how many do we go to the right? 1, 2. So my slope right now is 2 over 2, or just 1. All right, now, line A, or inequality A. Is it dashed or solid? You're right, it is dashed. And where is the shading in that one? Is it above or below? To me, it kind of helps more when I'm looking at the part of it that isn't shaded together. So looking here, is this shaded above or below line A? Above. I think I could have just circled the dash. We're going to do that. So it is dashed and it is above. So we are still going to be writing these kind of like we used to with y less than, greater than, less than or equal to, greater than or equal to mx plus b. I write all of those there because those are our choices now. So looking at how we have solid dashed above or below, let's talk about which one we're going to use. We have less than, greater than, less than or equal to, greater than or equal to. Sorry, sometimes you still mess them up. Greater than or equal to. So first of all, the line's dashed. So which 2 can we immediately cross out? The equal to's. And now it's shaded above. So is it less than or greater than? It's greater than. So we know we're going to have y is greater than what goes in for your slope, 1, so nothing, x, and then what's your b again? -2. So we have y is greater than x minus 2. All right, now let's do the next one. On line B, it's got a pink line. So let's start by finding the y-intercept on line B. All right, it's right here at 2, so we have 0, comma 2. So now let's find another point on that line. I kind of want to make it where we won't cross over much of that. Actually, I'm just going to erase that. So let's find another point on the line. All right, here's one. How many did we go? So going from left to right, are we going up or down to meet the next point? We're going up, so how many did we go up? 2, and how many did we go to the right? 1. So my slope is 2 over 1, or just 2. The next thing I want to know is my line solid or dashed? It's solid. And now let's check the shading. Is it shaded above the pink line or below the pink line? Below. All right, so now let's fill everything in. So we have less than, greater than, less than or equal to, greater than or equal to. Let's talk about what sign we're going to use. It's solid, so which two can we mark out? The first two. And is it shaded above or below? Below, so we have less than. So it should be y is less than or equal to 2x plus 2. And there you go. That's all you got to do for these inequalities. All right, or for these system of inequalities when you're writing them. All right, now let's do one more. Let's do 3b. So, starting with inequality A, that means this one, A. Let's check my y-intercept on that line. I'm going to do this one in green. Where do we cross the y-axis? All right, here it is at 4. So, what is my y-intercept? 0, 4. Now let's find the slope. Let's find another point on that line. All right, here's one. And when we say point, we mean corner. So going from left to right, do we go up or down to meet the next point? We go up, so how many did we go up? 2. And then how many did we go to the right? 2. So I have 2 over 2, which is really just 1. So my slope is just 1. All right, is it solid or dashed? It is solid, and did we shade above or below that line? All right, the only shading we have is above of it, so it is above. This one's a little different because we don't have all that extra shading to tell us where, so we just have to look at this line. I would cover up this line for a minute, the dotted line for B, and see where it is. And it's above. All right, so let's check what symbol we're going to use. To me, it's easier when I write them all down, and that's why I keep doing it. So we have less than, greater than, less than or equal to, and greater than or equal to. So we said it's solid, so we want to get rid of the first two. We know we're not going to use them. And it's shaded above, so that means it's greater than. So we have y is greater than or equal to x for my 1x of slope plus 4. All right. And now let's do the next one. So looking at the line for inequality B, where do we cross that y-axis? All right, we cross it right here. So my y-intercept is 0, -1. All right, now let's check out the slope. So we have one point here and we have another point here. So going from the left to the right, am I going up or down? Down. So we go down how many? 1, 2. So if we're going down, is that positive or negative? That's negative. And how many are we going to the right? 1, 2. So I have -2 over 2, which is really just -1. Now, is this line solid or dashed? You're right, it's dashed, and let's go up here to the shading. Is it shaded above or below? You're right, it's shaded above. All right, so now let's check out what symbol we're going to use. We have less than, greater than, less than or equal to, and greater than or equal to. So since it's dashed, which two can we mark out? Right, the ones with equal to. And since we're shading above, which one is it? Greater than. So we have y is greater than -x, because my slope is -1, minus 1. And that is all you have to do. That is your final lesson of the semester. That is your final lesson of the semester, and I hope you enjoy your winter break. Can't wait to see you all, or can't wait to teach you all again next semester.